Assalamualaikum and good morning. Today our group will present about volumetric analysis in titration.
Our group members, firstly, I am Muhammad Ishahmi. Then we have Amira, Nur Adila, Siti Nur Shafina, and Aimi Adriana.
What is titration? Titration is a laboratory technique used to determine the concentration of solution. It involves slowly adding a solution of known concentration called the titrant to a solution of unknown concentration until the reaction is complete. The endpoint is usually indicated by a color change with an indicator. By measuring the volume of titrant used, the concentration of unknown solution can be calculated. For example, titration can be used to find the concentration of an acid by reacting with a base of unknown concentration until neutralization occurs.
Now, let's talk about theory. Volumetric analysis is a quantitative chemical analysis in which the amount of substance is determined by the measurement of the volume that the substance occupies. This method is commonly carried out through titration, where a solution of known concentration is added to a solution unknown concentration until the reaction is complete. First, under type of titration, we have four main types. First is acid-base titration, involve a reaction between an acid and a base. Second is complexometric titration, used to determine metal ions such as calcium and magnesium. Third is precipitation titration, where an insoluble solid is formed during the reaction. Fourth is redox titration, which is involve oxidation and reduction reaction. Next, we have two methods of titration. First is direct titration, which involves only one reaction where the titrant is added directly to analyte until the endpoint is reached. Second is batch titration, which is involve two steps. An excess reagent is added first, and then the remaining amount is titrated with another solution. The determining of vitamin C in tablet juice is carried out using redox titration by direct titration method. Vitamin C acts a reducing agent and reacts with iodine. Starch is used as indicator to produce a blue-black color when excess iodine is present. Using the volume of iodine required, the amount of vitamin C in the table juice can be calculated.
So, Assalamualaikum and hi everyone. These are the methodology step-by-step procedure for the project. First one, the preparation. Clean and rinse burette with small amount titrant solution. Fill the burette above 0 mark with titrant. Next one, standardized titrant solution using known standards such as pure ascorbic acid solution. For the titration process, record initial burette volume and turn the stopcock to release titrant slowly into the conical flask. Then swirl the conical flask continuously while adding titrant. Reduce the flow to a drop-wise addition near the anticipated endpoint. Stop the titration immediately when the permanent endpoint color is reached. Last step is finishing and calculation. Record the final burette reading. Repeat the titration process at least 2 or 3 times. Check for concordant result. Titrates within plus minus 0.1 ml of each other. Use average of the concordant titrates for final calculation and calculate mass or concentration of vitamin C in sample volume using average titer volume and the known concentration of the standardized titrant.
Assalamualaikum and hello. Today I will be present about the determination of vitamin C concentration in tablets or juice using redox titration. So, principle of this experiment is based on redox titration where vitamin C or ascorbic acid acts as the analyte and the titrant used is iodine solution, which is commonly prepared from potassium iodide. Starch is used as the indicator and the endpoint is observed when a permanent blue color appears. In this reaction, iodine oxidizes vitamin C and the reaction follows a 1:1 mole ratio, meaning 1 mole iodine reacts with 1 mole of vitamin C. The titration was repeated to improve accuracy. So, the average volume of iodine solution that used was 25.12 cubic centimeter, showing a good precision. The concentration of vitamin C was calculated using the relationship between molarity and volume, which is M1V1 and equal to M2V2. The molarity of iodine solution was 0.005 molar and the volume used was 25.12 cm cubic. The volume of the vitamin C sample was 25.0 cm cubic. And we're gonna substitute into the formula and we're gonna get 0.00502 mole per liter. Therefore, the concentration of vitamin C in the sample is 0.00502 mole per liter. In conclusion, redox titration using iodine is an effective method for determining vitamin C concentration. The consistent titrate value indicate good precision and reliability of the experiment. Thank you.
For the conclusion, this experiment is successfully applied volumetric analysis using redox titration to determine the concentration of vitamin C in the sample. Iodine solution was used as the titrant and starch acted as the indicator to identify the endpoint through a permanent blue-black color change. The average volume of iodine used was 25.12 cubic centimeter, which gave a vitamin C concentration of 0.00502 mole per liter. This shows that redox titration is an effective and accurate method for quantitative analysis of vitamin C when the procedure is carried out carefully.
And this is our references for our presentation.
Thank you for watching. Don't forget to like.